Hello, this is Birdy. Welcome to a new lesson in Houdini. Today we'll continue our journey in our directing ocean fluid simulation in Houdini. Today we will dig deeper in the DOB network and take many techniques in how to change the velocity and control the velocity of the fluid in the DOB network. So let's get started. So let's continue, guys. Now we will start to change the velocity of the wave inside the auto dope network itself. But how can we do something like this? We have usually many options, but the main is two options. First one is speed pop speed limit. Okay, of course we will connect it to the particle velocity. Okay, because this is particle velocity and this will be particle velocity, right? This is a volume velocity. This is something different, but we will connect it to the particle velocity. Okay, this if we have a volume velocity. Okay, so we can simply just click the maximum speed like 15. So all the particle will not going to be more than 15 velocity volume. Okay, so if we have some splash going very fast, it will not going to cross 15. Okay, this is the first thing. Second thing, we can has more local control in many things, like the height of the velocity, as well as we did before with the velocity in the sub level in the last lesson, right? Also the velocity of the particle itself, or the vorticity, all this. So let's do some of this now. Let's go back. We have first to check the flat fluid. I think, yes, from here we can check it. We can make a comparison from the preview here. Here we have, let's say, particle. I only want to see the particle. We have the velocity here between 1 and 15. We will change it to be black and white. Let's say it's going to be black. So here the velocity between 0 and 10. Okay, so if we just hit play, of course it's better to make a caching for it, so we know the change that we have to do, or the fit range, right? So as we can see here, we have simulation. Okay, so maybe, of course, we need to add more particle or particle separation to reduce the number, so it will increase the number of the particle. When the number is more smaller, this mean will add more particle. Okay, now we can make like masking or fit range. So all this particle will have the speed of 10 or more. Let's make 15, for example. So this particle only will have the 15. Okay, and this is 10. So as we can see here, so if we want to control the speed of the particle, we can use the velocity, right? So let's choose, this was for demonstration only, so let's go back, let's get inside here, let's add geometry, sorry, geometry VOP, because the particle is a geometry, so we'll add a geometry VOP. Okay, let's get inside. So we need the length of the velocity first, so we'll make a length here, right? Let's go back a little like this. Now we will make a fit range to know the range that we want, maybe from 0 to 10. Of course, we added already 15, so all the particle will not going to move than 15, but let's say for 5 for example. Okay, so all the particle will not going to move more than 5, let's make it 20. Okay, and of course we can disable it for now, but since I choose 20, so it's fine. So we will use ramp, and this time we will add it to a mask. We cannot add it to the velocity. If we add it to a velocity again, the change that it will be from 0 to 1. It will be from 0 to 1, so there will not be any velocity at all. Most the particle will not going to move faster than 1, so we cannot add this here in the velocity again, but we can add it to a point export, right? And we will make it as a mask. Let's name it velocity vel underscore mask. Okay, and it will be a vector. No, I'm sorry, it will be a float, right? It will be a float. Okay, so we will just copy it, go back. Now we make a mask, but let's do the same thing that we did earlier in the particle surface, something like this. Okay, so the particle we will have, it will be the same as we see it in the particle surface particle, right, in the fluid geometry. So now we need to add a force drag and control it by this mask. So the particle which have a black color, it will not going to be affected, meaning the slow particle will not going to be affected by the drag force, while the white particle or the faster particle will be affected by the drag, and all this by the mask itself. So let's make a pop drag. Let's add it here. Let's name it vel, to understand that this pop drag controlled by the vel mask. Okay, but how can we add it? We have here group, but we didn't make a group, or we didn't make an attribute. This take an attribute, so if we make the bind as an attribute, we can use it here. We can simply type it here, and I think it will work. Okay, I didn't test it before, but this is supposed to be the but we will have to type it at, right, because it's called at vel mask, right? But this will be yeah, this will be the group. Anyway, we're not going to add it by a group, we're going to add it by expression. So we need the attribute that control the drag force. If we go here, maybe we can just make a little Okay, stop here. Let's see if we have something here. Where is, yeah, the point attribute that control the drag force, it's called air resisted. We can copy it like this. It's a plus as a point, or we simply can add it like this. It will add it to us here, right? Let's go at the beginning. It will be this erased, so we don't need all this other, we will just delete it. So we have the air resist, or we just simply can copy and paste it like this. Okay, so we will have air resist times the mask that we used, or the attribute mask that we choose. So what's the name of the attribute mask? Let's go back to the geometry again. Let's copy it and let's paste it here. So now the drag force will work only in the particle that has white color in the fill mask. Okay, so we can make a test. Okay, let's make a test now. Let's go to the camera and simply let's add a new render mask, new sequence, right? But we don't need the speed limit now. Let's so just we can see only the drag that we did, right? So let's make a new flip and start. Let's make here 150 only. Let's start. Okay, start. Okay, it's give me. Oh, I'm sorry. Hold on. So let's just add at here. So it should work now. Control enter. Yeah, it's work. Yes. Yeah, there is no error now anymore. So let's just simply add it here. Render. Oh, don't have any new sequence. So let's add flip new sequence 150. Let's add start. Yeah, so it added now a new sequence, and we can compare it with the last one to see if there is a different or there is no different. Okay, so let's see the different. Here is the file that we have. Okay, but let's compare it with the file that without the drag. So if we just here, if we stand in this one, we will find that there some particle has more force or faster, like this one is more up. In this one, most of the particles is not very fast. As we can see here, the particle is splashing bigger. Here we control the splash. As we can see, the splash is not very big, maybe this one only. Okay, but as we can see here, the drag work and it slow. It make the splash is little slower, so it will not going to move very fast or more or go further, go more away, right? So it work. So this is about the velocity. Maybe we can also control the vorticity. If we go here, we have a vorticity, but we have first to check it. This is the first thing. It will it will, yeah, make a viscosity attribute as well. Let's make a copy. Oh, I'm sorry, this is a viscosity. I'm so sorry. No, let's go to the particle vorticity. Yeah, this is the vorticity. Okay, we'll check it. If we want to see it as well, we can go to the fluid like this. Maybe stand here. So let's check the vorticity. If we check here, vorticity, now we have the vorticity. We'll make it blue and black like this. Maybe like this, maybe like this. So maybe we will decrease the number, reduce it by 20. So this part, as we can see here, this is the vorticity, that we have the vorticity here and the vorticity here. Okay, as we can see, maybe we can make it like more, 30, right? Make it 50, and so on. So we can make the mask now between 0 and 50. So everything above 50 it will be white. So we can reduce it. So let's go back. Let's get in the beginning. Let's get inside here again. We can make both. We can add it to the velocity we have, or we can make a separated as a new geometry VOP. We have the both option. Okay, maybe I will let's add geometry, or you know something, let's add it just here. So we have the vorticity, but as we can see here, we don't have the vorticity in the point attribute. This is all the point attribute that we have, or we can have, but we don't have a vorticity. So we can import it as a point. It's called vorticity, and vorticity is a float, right? Let's fit range 0 and 40, or let's say, yeah, 40. So all the particle between 0 and 40. Above 40 it will not, I think, yeah, everything above 40. Yeah, okay. So our limit is 0 and 40. Okay. Let's add ramp. Let's add the ramp, and let's name this Vorticity. If I type it correct. Control C, Control V. Okay. And we simply will add it here. Add it here. Okay. Let's go back. Let's remap it, maybe as we did earlier, like this. So now we control the vorticity as well. Okay, right, we control both now, the vorticity and the velocity. Will make it slow. Also we can add more noise for this. So for example, if we go back here, yeah, so we have this is the vorticity, but let's see in the velocity, just to be more clear. Okay, yeah, maybe we'll just make it like this. So let's add a noise for this one. For example, if we add point pop like this, Okay. Yeah, okay. Let's position. Let's add turbulence. Let's add, add, add. Or maybe we can multiply it. I'm not sure. Maybe we can multiply it like this. Let's see the color. Yeah, because we need one. Shift R. Yeah, as we can see here. Now we will have more randomization inside it, right? I think we can multiply. Maybe we can multiply it. Let's see the difference if we multiply it like this. Yeah, okay. Yeah. So I don't see a big difference, but I think the multiply is better. I think the multiply is better. I'm not sure which one is better multiply or add. But anyway, we don't need this. This was for demonstration only, right? So maybe we can add turbulence to it as well. More turbulence. Go to top network. It's right here. Oh, sorry. Need to connect this one. So we just need the position. Add turbulence. And turbulence will give us positive and negative, so we need to clamp it, right? So maybe we'll I'm really not sure which. Yeah, so I guess we will multiply it. We multiply the velocity that we have, the turbulence, with the result maybe, and then add it here, right? So we will have a mask, right? We'll have a mask. We can multiply it or we can add it, but in this case we need to clamp it, so it just give us 0 and 1, not more. And of course we use it as the mask. We don't use this as a velocity value, but we use this as the mask that control the drag, or the attribute drag arrest air resist, right? Okay, so we can make one last thing. Maybe we can also control it by the height, as we did earlier in the monster, right? We control it by the height, so we can control the fluid as well by the height. Let's stand here in 30. Okay, so we have our simulation. Let's just do it like this again. Maybe we want to control only, we want to control the drag force only in the wave inside. We don't want to control the splash, or maybe we want to control a specific height, right? So we add point VOP to see what I'm talking about. We get here, we make vector to float. Now we have the vector, we have the height, we take the y axis, fit range to know which part we want to mask. Then we add a ramp and vector float ramp. Let's add it like here, like this color. Yeah, so this will be the color. Now we can control which part we want. Make it like maybe like something like this, maybe something like this, right? So now we can control which part we want to mask as well. Yeah, what's going on here? Yeah, like this. So let's say, for example, we want to control this part only. We will have the drag force. The white only will have the drag force. It will be slowly. Okay, so we can control which part we want. Maybe something like this. Maybe we can control inside here the fit range. Let's do it like this. Let's promote it, minimum and maximum. So this is the minimum. If I go down more, so it will be -1 like this. Okay, if I want to go down the surface, and this will be up the surface or move it. Okay, so we have totally control in everything we want, right? Right or wrong? Right. Yeah, maybe we can maybe something like this, maybe something like this. So we have totally control, right? So maybe we will copy this one back like this, and go to the Autotop network geometry force. We can add it here as well, or we can add it in a new geometry. But since it will be by the way, I don't want to make it add both this. I want the vorticity. Okay, I want the vorticity and velocity multiply together like this. Like this. Okay, Shift R to reverse or to change the sort, right? Control V. Yeah, now we have the height. We can also multiply it here, and add a clump. Yes, add the clump here. So it would only be from 0 to 1. It will not, because turbulence give us -0 to 1 the value. So we want to start from 0 only to 1. That's all, right? All this multiply. We don't need this clamp here, and we just add it. So now we have many we almost have control about everything, right? There's a plus or minus. Oh, let's also say this was, I think, the height. This controls the height, right? Yeah, like this. And what's this? Vorticity. Let's say this velocity. Control C, Control V. Velocity. No. Control C, Control V. Okay. So here also we can control ramp velocity. Yeah, here we can also control the height and the distance. Yeah, right. Maybe minus 0.5, right? So we have all this control in the drag mask. Also, we can control the droplet if we have a droplet. If you go to the droplet, detect droplet, we can, the droplet is something different than the fluid itself. It is the fluid that doesn't have the function of the fluid. Mean it doesn't have a bond together, you know, doesn't clamping together or had a bond together. So it just act like a particle in the air more than a fluid, because the fluid has a bond together. It makes the particle become together, right? So now we can add also drag force. Bob drag. I think Bob drag and Bob force. I think Bob force, drag force, drag force. Let's test drag force. I think drag force work here. Yeah, drag force will be like a global drag, right? Right. Maybe 0.5. Of course. I'm sorry. It's in the drag, in the action, in the group, in the data. I don't see any. Yeah, scale to. Yeah, this is a scale force. Yes, 0.05, like this. Okay. So this is a drag force, and this is a bob drag. We can add bob drag as a global. It will work as like this. Okay. So what else do we want to do? Last thing, maybe we can add a drag force in the edge, right? So the edge has a drag force, but usually this work better with the volume motion with the boundary layer. The boundary layer drag have the power of drag. So every particle go here, it will become slowly, then it will suddenly stop or recede, right? So it work from the boundary layer, as we can, as we have a boundary layer here. If we see, no, not this one. Apply boundary layer velocity. No, we don't need. So it can work from the boundary layer itself, or we can make a box at the edge of this. Then we import it here. So let's make this. Let's go back. Let's go to the initial fluid. I think this one, yeah, has a box size. Maybe we can just make it 14. Oh no, sorry, just 14. Just 3. Okay. Let's make a box. Let's make the box here. Let's make the box have the same size here. 20, 20, 20, 20. Is it 2020? Yeah, 2020. So here is our box. Let's give it more thickness, maybe something like this, and we want to reduce it. We want this part only, right? So how can we do this? Very easy. We can add another one, Control C, Control V. We can bond it, bound. We add bound, right? And then we increase it here from the X and Y, as we can see here now. Maybe -2, and here -2, and here let's just copy this, copy parameter, paste parameter reference. Yeah, so yeah, and let's copy parameter, paste parameter reference, and no, copy parameter, paste reference. I think we can also drag and drop it. So let's say -1. So as we can see here, we increase it just a -1, right? Let's make it a little bigger in the like this, maybe. Let's make it this 4, and let's make this 2. Okay, we have the bound now, and let's boolean this from this. Let's make boolean, right? This one, make the boolean. Subtract, let's see the different. Nothing happened. Shift R, yeah. So now we have the box that we need. We can import this box as a VDB. Let's say it's a VDB from Polygon, right? It become a surface now. Let's make it null, and let's name it out edge drag force, right? So we have it now. Maybe we can give it a noise as well if you want, maybe, but we will have to make, I think, anyway, we can add by volume VOP to add it a noise, or we simply just take it as it is. Maybe we can just, sometimes I need to do something, volume VOP, I think no, I think we can add it by volume VOP or attribute noise. I think attribute noise will work as well. Attribute noise, let's check attribute noise, but we have the color here. We need to have maybe the position. Let's check if we have the position as well. What's going to happen? Nothing happened. Was it called surface? If we check this surface, paste surface here. Yeah, I'm sorry. Fog VDB. No, I'm here. Surface. No, but it move all of it. So it's better to make it by the point VOP. Yeah, we can make it by the point VOP. Yeah, great. Seeing that the file, yeah, let's save it because I don't want the file to crash. Volume VOP, and we we simply can, but I'm sure there was a way to make randomization for the velocity. Not sure how. I think, okay. I think it's from the sample. We can add a sample, but you know what? I'm not going to make it now. Let's just have it same as this for now. Let's go back. So let's get inside here. Let's add new attribute Wrangler or Wrangler attribute Wrangler. Yeah, so let's continue. Add another one. We need a pop Wrangler, I'm sorry, because we are in the particle now, so we will use a Pop Wrangler. Okay, but we want to have the input here, input 1 in the sub level. Let's choose it. Where is it? Okay, so I think it was in the initial, yes. Out edge, yes, this one, accept. So we have it now, but we need to make a mask for it. So let's make it h underscore mask equal volume sample yes. Here we want the first input, right? The first input will be 0, then yeah, so I think it will be 0 because input 1 is 0 and 0 and add point, right? Let's see if we go to 2 if it's going to work or not. It didn't work. Yeah, sorry, I figured out the why it wasn't working, because I was putting shift this 2, right? That's why it wasn't working, right? So it's just like this one. In this case it will work. Close, back. Oh shit. Yeah, so the file crashed, but no problem. Let's go back, enter again. Let's type it again very fast. Pop drag, sorry about that. It saved a backup file, but to be honest I'm not sure where it saved it. But anyway, make sub level. We said it was in the initial H force. Now we will no, shit, not the pop drag, Pop Wrangler. Yeah, sub, yeah, this one. So let's type the code this time correct. At h underscore drag equal volume sample this, let's say first one 0. So 0, it will be the first input. The input number 1 is 0, input number 2 is 1, input number 3 is 2, and so on. No, 0. And let's say add point, and that's it. Now it's working. Yeah, perfect. Go back. Just go back. Hit S. Let's do this. Yes, okay. So let's add another bob drag. Last one this time. Let's use expression. It was, I think it's called arrest or something like this. Let's just copy this, Control C, Control V, but we will choose this name. Add fill mask. Edge drag, yeah. Let's hit play. Okay, it's not working. Add edge drag. Why it's not working? Yeah, I'm sorry, it has two add, so just one add. Go back. Close. Yeah, so it's working now. It's just working. Thanks God. Now we can control the air resistant of the bob drag. Air resistant activation. When we control the activation, let's say, for example, we'll just make this like this. Let's say, for example, if we want to make the drag force start from here, right? So we'll simply, we can type a code. We can say at we can say, we can make a keyframe or a code, right? But I will make a code $F bigger than, let's say we want the drag force start working from after frame 20. So it will be like this. So all this it will be 0, it will be 1 1 1 1 bigger. Okay, yeah, sorry guys. So it will be this is smaller, so the frame is smaller than 20. So every frame, if it's smaller than 20, like 1 or 2 or 3, it will give us 1, but we want the other, so frame is bigger than 20, right? Just make this one. So let's check if it's work or not. Yes, 0 0 0 0 0 after 20. It's becoming 1, right? So it will work now. So the code is working, right? Or we can just simply, I will make the other one here. Where is the other book drag? Yeah, just simply make it here. Just think, maybe I want this one to start working from 30, for example, 30 like this. So here it will be 0, put a keyframe, and here I will put 1. Yeah, by keyframes. Okay, but of course the code is much easier. Okay, so next lesson we will continue our art directing. And that was the end of this lesson. I hope you enjoyed. If you have any question, please type it in the comments below. And if you want to support us, you will find links to Patreon and Gumroad below the video. and we will appreciate your support. Thank you and see you in the next lesson. Have a good day.